So let me walk over to my robot. I'll be doing a live demo for you guys. This is me here. The robot's a whole lot prettier than I am. But I want to do a live demo today showing off the Techman collaborative robot and how easy it is to set up an application. So quick bit of background on Techman Robot first. They, in about 2015, came in and they're part of the Quanta Group. And the Quanta Group is one of the world's largest manufacturers of solid state drives and laptops. And they saw a need in their facilities for collaborative robots. So specifically needed to work around people, needed to be safe and easy to use. And they surveyed the market and weren't terribly happy with what all was out there. So they said, you know what? It's early in the market. Let's see if we can develop something of our own. And what they came up with is what you see in front of you. So this is the TM5 700 6-axis collaborative robot. And their philosophy was they wanted to make robotics easy to use as a smartphone. So like Juan had been talking about, there's tons of development in software and processing power these days. And Techman really wanted to harness that and make that incredibly easy to use. So I'm going to set up for you in about 15 minutes here a vision-based pick and place demo. And this is just kind of a fun one here. And what I'm going to have a robot do is identify this little fixturing tray. Fixturing, I use that very loosely. It's going to identify that based on that landmark. It's going to orient itself to that fixturing tray. And then on that tray, it's going to look for the little snack I had laying around the office, in this case, a Pringles can. It's going to identify that, find it in the space, and do a vision-based pick and place job. So let me walk over in a second here. And I'll when I do that, I'll show you the programming interface. But for right now, I'm going to show you some of the basic controls. So ease of use is huge with the Techman robot. There's a free move button here. You're not wrestling with a big pendant. You've got two hands to manipulate the robot and get it into a position you like. And then you can actually program points with this point button here. You can add vision jobs and program them with a button right on the robot here. And then you can even, if I rotate this around, activate the gripper with a button here. So you can very quickly lay out in just a matter of minutes a job where, simple pick and place, move from point, program the point, move to another point, so on down the line. So as I walk over to show that interface, let me share my screen here real quick. If I can find that button, hold on. Okay. So what you're looking at here is the empty screen of the Techman robot interface. This is called TM Flow. And you'll note that this isn't lines of code like you get with a whole bunch of other robots. This isn't a very cluttered interface like you see on a little tablet if you're programming on your robot. This is just a nice big flowchart based programming screen. So I can drag nodes in from the side here. And those are going to represent various functions for the robot. So this is very simple and easy to follow logically and very intuitive, particularly for new robot users. So setting up my demo real quick, the first thing I'm going to do is I've got my robot in kind of a neutral position where I'm going to look over that workspace and I'm going to try and identify that landmark. So I'll drag in this vision node and I'm going to bring in this landmark job. And admittedly, I created this a little bit earlier just to demonstrate to you guys. I could show you how to do this. It takes a couple minutes, and mainly it's adjusting things like contrast and lighting and all that kind of thing. But I'll show you the basic flow. So the first thing it's going to ask me to is I've got a pre-programmed initial position that it's going to move to. So you should see that in the live feed as the camera moves, and then also on my screen. If you're in that speaker view, you should see the robot slowly moving into position. And this slow movement is something that Techman locks in a lot of places. That makes it very safe. At that kind of speed, anybody can get out of the way if they weren't expecting the robot. So the first things that this job is going to do, there's a couple nodes that I've added here, and it's just going to very quickly and simply identify that landmark. So you see that landmark there is highlighted in green. If I move it around that space, it'll track that landmark. Okay, so pretty straightforward. So I'll save this job and I'll go back to my my main program. All right, so what that has created for me is this little orange icon here with the 2 with the eye. That's created a virtual workspace that I can now program moves on. So if you can imagine a Cartesian plane centered at that landmark, that's now this little eye number 2, and I can drop down from this from that menu and program moves on that base. So now in this case, I want to do a second vision job because I want to zoom in and I want to identify that Pringle can, and I don't need to see all the space around it. And there's some logic built in tier 2, right? So it gave me the option to do a pass or a fail. So if it doesn't see that landmark, I've got an option to do something there. So I'm going to load this second job again. This is one that I created earlier. It doesn't take very long. It would only add about 10 minutes to the program, but me adjusting camera settings is not terribly exciting viewing. So this one also has a position recorded, but this position is recorded relative to that landmark. So this is going to zoom in on that landmark. And at this point, I just want to see this tray. So you should see that now. So there's a couple processes that are going on here. The first is I want to identify that blob. So this is just looking for that red color, and that's going to give me a zone that I can use to narrow down my search area. So I'm going to do a couple enhancements. I'm going to kind of knock it down to grayscale. I'm going to up the contrast to bring out that little logo there that says the original. And I want that barcode to have some good contrast. So now I trained a shape. In that case, it is that original, that text there is a shape I trained, and you can see it's locked on there. I've got some confidence values for my vision job, so it's got a good fix on it. And then relative to that, I'm identifying that barcode, and I've got a variable that I can output that's going to give me that barcode so I can use that later. Okay. So I'm going to finish that job. So going back to the main programming screen, now I have a vision base based off of another vision base. So this has done 2 different jobs, bringing it all together very simply, and I can program moves now relative to both of those. So in this case, this drop down here, number 3, is going to be based on my Pringle can. All right, so now comes the really easy part. All I have to do is move the robot around and actually have the thing pick something. So I can move that at all joints like you would any other robot. The Techman has a couple special modes for free movement where I can lock it into either just a Cartesian mode or just a rotational mode, or in this case, I'll use a Scarab mode. And that's going to make it really easy for me if I stop sharing here and switch over to my video. Let's see, you should see my robot now. That's going to make it very easy for me to grab this robot, and I'm perpendicular to this workspace, so I don't really want to lose that by unlocking all joints. So in that Scarab mode, I can just grab it, guide it in very gently, and that should do there. Now, of course, that kind of rough positioning is not exactly what you would want for a lot of applications. You can use it though, but I can go in and I can refine this point. So if I want to update this point in my controller and say, adjust it either at the joint or at the robot base or relative to the tool, these are all things you would expect with pretty much any standard robot, and you got them all right there. So you're not forced into oversimplicity.
Grayson, I don't believe we can see
I forgot to
your
switch my screen
computer
back.
screen.
Sorry about that. A lot of juggling between screens here. All right, this should be a little better. You guys should see this now. So I added that point, and now I can go in and I'm not left with, like I was saying, just that rough hand-guided point. I can go into my point manager and I can control it from directly at the joint angles, or the robot base or the current work base, or make adjustments at the tool. And I can jog those around. I can go directly to those, whatever I might need. For this demo, not a problem. I like where it is. And I'll program what kind of move. So I can do either a joint type move, a point to point, a linear move, or in this case, a waypoint type move, which is unique to Techman, and it blends those 2 points. All right, so now that is going to be on this vision base relative to where I go. So it's going to come down, grab that, and move to that position. And then I will do a gripper command here. So this is a little module from the plug and play library that Techman has with all the various vendors they work with. In this case, Robotique. And this is just a simple dropdown that gives me some logical options for what that gripper sees. So it's telling it to grip, and it'll send a signal if it's detected or not detected, or if there's an error. Nice and easy. So once I've gripped something, of course, I'll probably want to wait for a moment to close the gripper. Pretty standard. And then we'll do a relative move back up, just so that we can clear the table and move over to wherever we're gonna drop the part. So I'm gonna drop in a relative move. It'll be negative 100 millimeters in the Z axis relative to the tool. And then I will swing the robot around and have it drop the item somewhere. So in this case, all I have to do is grab it, walk it over there, and add the point. Whoop. So here's a little error I made, and this is a very easy one. That you can see the icon there is relative to the vision base. I don't want that. I want that relative to the robot base. So I just switch over from this drop down here, add that point again, and now this will be fixed relative to the robot. So all pretty easy stuff. I'll do that node there, which is the release node, and it'll drop that part. And then once it's done that, I can do a quick, I'll add a pause so that I can have the robot pause for a second, let me reset everything so we can cycle this. And then I'll do like a jump node, it's called a go to, where I'll jump right to the beginning of the program and do this all over. So pretty simple. So we can see, looking through this program, very, very simple. And all these little gateways, it makes it very clear in this sort of organization what things are missing and where some hangups could be. So for my first landmark job, for my first node here, well, I don't have a fail path, so it doesn't see the landmark. I could potentially get stuck and lost in the program forever. If any of you have ever been programming and forgot to put an end, somewhere in your program, you can understand how frustrating that could be. Easy to spot here. In this case, I'll just bring that to a pause, and then I'll cycle it right back to that same job so that I can repeat. Same thing if it doesn't see the Pringle can. Maybe in that case, I'll wait for a couple seconds just so I can get up there and rearrange the Pringles, maybe 5 seconds, and go back. Similarly for the grippers, I'm gonna, for this purposes of this demo, I'm just gonna have it continue on no matter what, whether or not it sees that can. Oops. Drag the nodes down. And that's it. That's a program there. Not much to it, very simple. But the task is to do this in code and integrating a camera and all of that. Very complex. So let me switch back over to video and we'll try out the program. So you see the robot's going to start at 5% speed. So very slow, and Techman forces this so you can catch any errors. And in this case, I made another error. I didn't force my gripper open at the beginning. That's a very simple kind of error to make. But if you have to dig through hundreds of lines of code or something to find that can be a bit of a pain. So with the robot, I can just highlight all those nodes. And I'm going to, at the beginning of the program, drop in a open node. untangle some of my spaghetti here real quick. Whoops, and I think I need to share that video again.
Yeah, so when you're doing that, people are seeing the video as well if they're in speaker view, and they can adjust the relative size. So you can just stay as you are right now because we can actually see the robot as well.
Okay, great. Sorry about that, folks.
No worries.
Yeah, so as I was saying, very easy if I need to grab this whole program here because I missed something, I want to insert something before my program. It's very easy. I select everything, I move the blocks around, and then I can just drop in my new node. So now this will force the gripper open right at the beginning. So simple to work with. And Techman has a huge range of parties. So this is not a particular gripper. This is a particular gripper node to Robotique, but you can use Shunk, you can use on Robot, you can use Toyo. There's a ton of options. All right, so now let's try this program again. We'll play it, and you'll see in the top right corner here, that's my run speed. So the Techman's always going to default to 5%, as I said, to catch any errors. So I'm going to run it slow. So as you can see here, it's found that landmark. It's orienting to that orienting to it, moving to the next space. Takes a picture of that Pringles can, sees it, grabs it, and it's going to take it over to that point. That could be dropping it on a conveyor or whatever it may be. In my case, I'm just dropping it straight to the floor. So I'm going to shift that landmark. I'm going to shift that Pringles can, and we're going to run this again. And I'll speed it up a little bit. So 20% speed now. It sees the landmark in the new orientation. It sees the can in the new orientation, picks it, no problems at all. So that's a very basic demo, but as you can see, put that together in all of 15 minutes. And to do that again, integrating a third-party camera plus a robot with more, little bit more complex looking code, catching all your errors, that can really add up. So the Techman makes it very simple, very quick. That means folks who don't have a robotics background can pick it up. That also means if you do have a robotics background, you're going to save a lot of time on the programming side. And of course, time is money. If you can turn a project to your customer faster, that's all the better. So that's about the size of that. I can take some questions. I think I've got about 10 minutes or so.
Yeah, we've got about 8 minutes left here, Grayson, for some questions, and we've got a couple coming in. By the way, this is Lily. I am the other half of the robotics team. I'm helping out Andrew today by being the question guru. So as your questions come into the chat box, I'll be taking them from you.
Okay.
So the first question is, why use a collaborative robot instead of a 6-axis robot?
So a collaborative robot versus a traditional robot, there's two major advantages. The first and kind of the most broadly talked about and obvious is the safety. There's a whole set of sensors in collaborative robots. Generally, it's done by monitoring the torque and the encoders at each joint. Some robots do it with a capacitive skin. Some do it with a force torque sensor, but basically it can detect if it runs into either itself or the machinery or hopefully not a person, and it'll stop itself before it can do any serious damage. The second, and I think the one that for a lot of folks ends up being even more important actually, is the ease of use. So traditional robots, being an older technology, tend to have a little bit an interface built more for older technology, kind of that smartphone thing again. They had less processing power, so if you can imagine trying to run robots off of Windows DOS or something, right? Versus a modern robot, and these collaborative robots, very new, have a much sleeker interface like a smartphone does. So that's kind of the short answer. So safer and easier to work with.
And I know that the Techman has some cool safety features built into its software. Someone was asking if they could just see, some of the basic software for safety.
Yeah, absolutely. So I'll flip over to the safety tab here. one big thing with collaborative robots, they'll stop when they're
We
hit with
need to
something.
see your screen, Grayson.
Did I stop sharing it? Darn it. I'm sorry.
It's okay.
All right, take two. So I've gone into my settings here. And this is something that Techman has that makes the safety very easy. Most collaborative robots, they'll stop when they bump into something, but you still have to program every single move to make sure it meets the ISO standards to be considered collaborative safe. So in free space, that's 250 millimeters a second. But Techman has those standards, and they're all specific to where it could potentially interact with a person. So in this case, hands and fingers knocks you down to 180 millimeters a second. But if your project scope changes and maybe you need to make it safe to be around shoulder or something, knocks it down to 162. And then, potentially if it could sweep out your leg, it knocks you all the way down to 72. And so Techman, you can load these standards, save those so that your robot kind of has an understanding of where it's operating. And then you can toggle a collaborative mode that the robot will be in where it will safety stop itself if it's ever programmed for some reason to exceed those speeds. And that collaborative mode can be triggered either with a virtual plane or by a laser scanner or a light curtain, or just a gate switch or something. So tons of options, makes the safety setup very simple.
All righty, cool. And it looks like we have some other questions. One is, someone is asking, is there a simulation mode in TM Flow?
Yeah, so in the TM Flow software that you're looking at right now, there is not. There is a view that you can get to when you're running the robot that will show the robot in 3D space, but that's not really a simulator. Techman has a 3D environment for setting up the robot. It's free, you can download it, and you can load your robot, you can load your tooling, and you can do kind of reach studies with it. And then and that's very basic, and you can export a set of points in like a basic program from Studio into TM Flow. And then there's third-party options as well. So one that is a plug-and-play option for Techman Robot is the AutoMaps software, and that's a full-on simulation and programming software that you can then take that and export to the robot. So hopefully that answers your question.
And then we did have a question about setting the force generated by gripping the can. So someone is wondering, how did you set the force while gripping the can?
Yeah, so in this case, what I did was, and this is particular to this Robotique gripper. I've got this little wrist adapter here, and this particular one I program just over USB on my computer to have 4 different settings. So I've got basically 4 different presets, and they're just toggled by the discrete outputs right on the wrist. And that gives me the option for how far and how much force. If I had a different wrist adapter there, they've got a version that'll communicate over the serial connection, and that one I can adjust that a little bit more live on the robot. Shunk and on robot will have other options for doing that as well, some live, some presets. So kind of depends on your gripper, but a lot of options there.
And I think we're hearing from those 2 gripper companies today, so we'll learn a little bit more maybe about that technology. And then final question, we only have about 1 minute though, so maybe you can make it quick. What are some common applications for the Techman cobot? Oop, Grayson, I think we lost you.
Can you hear me now?
Yes, I can.
Okay, sorry about that. I bumped my mic. So by far the most common for collaborative robots right now is machine tending. So just pulling stock or finished parts in and out of machines. It's easy to set up, and with something like a collaborative robot, that ease of use means you can introduce a robot in facilities that are much smaller, and to folks who would never have expected to do that kind of thing. So a lot of small shops are doing machine tending jobs now. The second is things like material handling. As Juan had mentioned earlier, There's a lot of folks just picking a box off a conveyor line, setting it on a pallet, and then doing that all day long. That is a miserable job that really hurts if you do that all day, every day. So if you can take that person and uptrain them to do something else and then put a robot in its place, that's huge. That's a huge pain saving for the person working, and that's can be a cost saving for the factory as well. So that kind of is the second one. And then after that, you'll see things like polishing and deburring, some food, things like that. So, but the two big ones are definitely machine tending and some material handling.
Awesome. So thank you so much, Grace.